WKO Metrics for BaseCamp coaches, Functional Reserve Capacity, or FRC. Let's start out with a quick definition of FRC. FRC is the total amount of work that can be done during continuous exercise above FTP before fatigue occurs. It's typically measured in kilojoules, sometimes in joules. The key thing here, and I think this breeds a lot of confusion with our athletes, it's continuous exercise, meaning that doesn't tell you how many times you can burn matches or how many matches you have in your match book. It doesn't tell you how many times you can repeat hard efforts. Now, there is a relationship between the size of your FRC and those capacity or capabilities, but it is not like clean, neat, and linear, and I'm going to show you why at the end of this presentation. So remember, it's continuous exercise above FTP before fatigue occurs. You can see FRC in WKO. It's one of the hero metrics, and it's in multiple power duration models. Sometimes you'll see it lined in the power duration model. We don't always put it there because it's kilojoules, and this is watts, and that can confuse people. But oftentimes it's pulled off to the side like that. Plenty of charts and reports in our WKO basic chart pack all have FRC kind of more pulled off to the side. You don't always see it in the power duration model. How do we measure functional reserve? Well, it's a model output number. It's based on the power duration curve, which is based on your mean maximal power contributions. Now, this means your model must be maintained. If you don't have a maximum short, medium, and longer effort, so I don't know, 5 to 10 seconds, 60 to 90 seconds, and something out there around 20 to 35 minutes. If you don't have good hard efforts in those ranges, your model might be a little bit off. But it is derived by the power duration model, and it uses all the data. It doesn't use anything specific in there. FRC is actually one of the parameters of the model. So model-defined FRC is very similar to what's known as anaerobic work capacity, except it gives a little bit of credit to the aerobic contribution. Now, traditionally, we think anaerobic is in the absence of oxygen, but that's not really true. When you look at the actual power output, there is a little bit of aerobic contribution. You could prove this to yourself or any one of your athletes with a simple experiment. Get on your bike, warm up, point your bike up a hill and do a maximal 1-minute effort. That's anaerobic. Anaerobic is the dominant fuel source, right? Anaerobic glycosis. But the reality is you're going to be breathing pretty freaking heavy at the end. That extra demand, you are bringing in some oxygen contribution. So we believe FRC is slightly superior to anaerobic work capacity because it's taking into account those couple of extra watts you're getting aerobically. Once your FRC is depleted, you must rest and recover. You must drop below FTP to recharge that battery. FRC is a measurement of anaerobic work capacity, as I just said, with a little bit of the aerobic capability, and it reflects the energy output capacity of anaerobic glycolysis. What does it do, or when do you need it? Long sprints, sprint lead-outs, short power climbs, brake power, like if you're really doing an acceleration to make a break or get away from the peloton. And it does supplement your aerobic capacity. Having a higher FRC gives you that ability to put a little more. You don't want too much, actually, when you're talking about aerobic capability, but put a little more energy on top of your aerobic capacity. What are the ranges we see? Well, the average for a male is 16.2. Under 12 is low, 12 to 20 is medium, 20 plus is high. Just note there's a fair amount of pros. This is the original WKO database. It's probably the honest real world is probably 20% less. I should have put that number in here, 20% less. Same for female, 10.8 is the average, under 7.5 is low, 7.5 to 14.5 is medium, 14.5 and above is high. So with that background of FRC understanding and just understanding the basics of it, let's talk about a consistent mistake in application. And I get this question a fair amount publicly, and I know some of our coaches have had it. So when you have FRC, and you have this idea, you have to learn to use FRC wisely because there's a relationship between your Pmax and your FRC that you need to think about. So to demonstrate this, I'm first going to take this performing athlete and I'm going to round out some numbers. I'm going to take their Pmax and just make it 1,000 watts. So we're going to steal 16 watts from this athlete. Then I'm going to take their FRC and I'm going to round that to 15. So I'm going to steal 0.2 kilojoules from that. But I'm actually going to do one more step. I'm going to make that 15,000 joules. So a kilojoule is 1,000 joules. So I'm just timesing that by 1,000 to get 15,000 joules. Now the reality of Pmax, it's the maximum burn rate. It's how quickly you can burn through your FRC at max effort. And this is a confusion for a lot of athletes because I almost should have done this with a second athlete. Let's say this is athlete A, right? And athlete B, imagine here a 500 watt. They only have a 500 watt sprint. That reality is when we compare, and let's say they both have the same 1500 kilojoule, we could do math to determine how quickly at Pmax this athlete would burn through these 1500 or 15,000 kilojoules. And it really, this is the math you would do. 15,000 joules, that's what they have available in their anaerobic work capacity, or that FRC, that anaerobic battery above threshold in a continuous effort. Now we think about dividing that by 1,000 watts. A watt is a kilojoule per second, a kilocalorie. It's the same thing, right? So we can divide 15,000 by 1,000 watts, and we could predict that this athlete could go at Pmax for about 15 seconds till their FRC is depleted. Now, I'm going to tell you something for what I just said. Redo that math in your brain. You could do this math for every one of your athletes because Pmax is the maximum burn rate, and this is the size of the battery. So all we're doing is tracking the maximum burn rate. 1,000 watts is 1,000 joules per second, same thing. And the reality is at 15,000, 15 seconds is the end number. So the math is easy. Now I need to caveat that as for the correct physiology. Fatigue is multifaceted. It's highly unlikely that this athlete can hold their Pmax for 15 seconds. Other fatigue factors will probably have the athlete dropping off around 5 or 6 seconds, maybe 7 seconds, maybe 8 seconds, because fatigue is multifaceted. It's not just the size of the tank, how much fuel you have available. There's a neuromuscular demand, there's a neural coordination demand, there's ATP demand. There's different factors impacting that. But in a perfect world, if you just isolated that FRC, they could do 1,000 watts per equals 15 seconds, or 1,000 watts for 15 seconds. Now let's talk about this. I have one more little piece, but I want to talk about this. So I get asked by coaches all the time, but my athlete has a higher FRC, but they can't bring it to bear at the end of a race, or they can't do it like what they think. Well, oftentimes I hear that from people with high Pmax. So if you're an athlete with a high Pmax, like let's use this example, and his Pmax is not that high, but even at 1,000 watts, he only has about 15 seconds of max sprint. Again, there's other fatigues, so he can kind of probably still use FRC out to about 20 to 25. It's a good measurement of that. What if he had a 2,000 watt sprint? He would take that 15 seconds and reduce it to 7.5 seconds. What if he had a 500 watt sprint or 500 watt Pmax? Well, then he would extend that out to 30 seconds. And you have to really think about what I'm saying, because this is an impact that confuses athletes. I see athletes with a solid kilojoule and a higher Pmax, but yet they feel like their FRC is overstated, or they just can't access it, or they just can't repeat it. Maybe the problem is they can burn through it so fast. Coggin used to say all the time when we talked about this type of training and anaerobic work capacity, when you have this kind of power, you have to use it wisely. A good, somebody with a phenotype that's even more time trial than this is a sort of continental pro. they might only have a low P. They can't really hurt themselves quickly. They end up looking like they can repeat more because they can only do 500 watts and their hard efforts are and I shouldn't keep saying that 500 watts is not a bad sprint, and 400 watts, or they're doing their surges at 300 watts. That's because they're not burning through their FRC as quickly. So when you have an athlete that's pushing back, because I've already gotten this question, I received a very similar question twice in the last month from our coaches. One of the things you immediately look at is what's their Pmax, how dangerous is that athlete to themselves? And oftentimes then if you look back through their files, they're using what they can do here too often, too frequently. So you have to teach them maybe to keep that powder dry because they are dangerous to themselves. They can burn through that kilojoule basis very quickly. All right, in closing, one reality is this, you can't do the equation by saying, oh, well, if they went 500 watts, they could hold it for 30 seconds. That's not true. Once you drop off Pmax, there's other things that impacts the burn rates. There are other factors that will impact the burn rate. Oxygen, VO2 contribution, things like that. So O2 contribution, things like that. So understand that you can only predict this off Pmax. Hope that helps. Don't be afraid to ask questions.